Hello, how we all doing? We're going to talk today about operations with complex numbers. So, jumping right into the material. Working with complex numbers, algebraically, is just like working with any other binomial, except the exponent of that I must be a 1. The reason that is if you have any other exponent on the I, you can simplify it down to something else. If you have I squared, it turns into -1. If you have I to the third, it turns into -I. If you have I to the fourth, it goes back to just a 1. So the exponent on the I has to be a 1. It can be anything else. Doing a couple examples here very quickly. When you are adding or subtracting, it's just like working with any other binomials, trinomials, any other polynomials. You want to combine the like terms. So let's go ahead and simplify this a little bit and see if we get any like terms. So we're still going to have our 5 here out in front. The square root of -36 ends up being a 6i, because the square root of 36 is 6, and it's a negative under there, so we want it to be imaginary. Plus, the second set of parentheses here has a 3 minus the square root of -16. Well, the square root of +16 is 4, so the square root of -16 is 4i. Now we want to look at this and see, okay, what can we put together? Well, I notice that I have a 5 and a 3 that can go together, which will give me an 8. And I notice that I have a +6i and a -4i. When I put those together, I end up with +6 minus 4 is +2i. And that is it. You cannot put the imaginary together with the real. It is 8 plus 2i, another complex number. Looking at example number 2. Same kind of thing, we want to get rid of those parentheses. So the first set is just a 1 plus 3i. Now we have this subtraction sign in here that we want to get rid of. So we have to distribute it to both of the things in the second set of parentheses. So that's going to be a -3 now and a -2i. Once again, we see that we can put 1 and -3 together, giving us a -2. And we see that we can put +3i and -2i together, giving us a +1i. Now you want to leave it that way, even though the 2 is negative in front, because that is standard form of a complex number. You want the I to be at the very end. So -2 plus 1i. Third one, getting a little trickier here. We want to simplify this down as much as we can, so let's break down the first set of parentheses. We're going to have our 2 plus, well, -8 can be broken up into the square root of -4 and the square root of 2. Plus, second set of parentheses has a 3 minus, and -20 can be broken up into the square root of -4 and the square root of 5. So when we simplify a little bit further, we're going to have 2 plus 2i square root of 2 plus 3 minus 2i square root of 5. When we combine what we have together, we have 2 plus 3, which gives us a 5. And these other 2 here can't go together because we have a radical 2 and we have a radical 5. So we just tag them onto the end. Plus 2i radical 2 minus 2i radical 5. If we're multiplying complex numbers, it's the same thing as multiplying any other monomials, binomials, polynomials. You're going to use just the same rules that you use on everything else. So for this first one here, when you're looking at this, if we want to multiply 5i times negative 2 plus I, you want to go ahead and distribute that. Distribute the 5i to both of them inside. So 5i times negative 2 is going to be negative 10i, and 5i times positive I is going to be plus 5i squared. Now we need to simplify that, because you can't have any exponent other than 1 on your I. So I squared is actually, if we recall, negative 1. So this turns into negative 10i plus 5 times negative 1, or negative 10i minus 5. You want to switch that into standard form for a complex number, so you'd want to have negative 5 minus 10i as your final answer. Example 4 is a little tougher because it's two binomials. We want to go ahead and FOIL that out. So we want to do our firsts. 7 times negative 1 is negative 7. Our outers, 7 times plus 2i is plus 14i. Our inners, negative 4i times negative 1 is plus 4i. And our last, negative 4i times positive 2i is negative 8i squared. Again, we need to go through and simplify that, so we're going to have negative 7. We can put positive 14i and positive 4i together to get plus 18i. And once again, this I squared at the end here is going to turn into a negative 1. So we have minus 8 times negative 1. So negative 7 plus 18i plus 8 gives us, as a result, a positive 1 plus 18i. We have that in standard form with the I on the end, so that is our final answer. Pause the video here, give number 6 a try, see what you can get. Alright, so once again we want to go through and FOIL this. We want to do our firsts, which is 6 times 6, or 36. We want to do our outers, 6 times negative 3i, which is negative 18i. We want to do our inners, positive 3i and positive 6, which is positive 18i. And we want to do our lasts, positive 3i times negative 3i, which is negative 9i squared. When we go ahead and simplify that down, that I squared again is going to turn into a negative 1. Our inners and our outers in this case are actually going to cancel out. Oops, I forgot to write my I on there. Because we have negative 18i plus 18i, so those cancel. So we have 36 minus 9 times negative 1, which is 36 plus 9, or 45 is our final answer. So if you notice in the last example, the product of a complex number and its conjugate was just a monomial. It just had one term. We can use that to divide complex numbers. Imaginary numbers are really just a radical, right? It's the square root of negative 1. So because they're a radical, the division of complex numbers is actually just asking you to rationalize the denominator. So looking at example 7 here, if we want to rationalize this denominator, we're going to go ahead and multiply through, well, it's a binomial on the bottom, so we want to multiply by the conjugate, or 1 plus 2i. 1 plus 2i on the top and on the bottom. So we're going to have to FOIL out the top. 5 times 1 is 5. 5 times plus 2i is plus 10i. 3i times 1 is plus 3i. And 3i times 2i is plus 6i squared. On the bottom, we're going to do 1 times 1, which is 1. 1 times positive 2i, so plus 2i. Negative 2i times 1, so negative 2i. And negative 2i times positive 2i, which is negative 4i squared. Again, we want to simplify this down a bit more, so you're actually going to see that this I squared here and this I squared here both turn into, that's right, a negative 1. So we're going to have, on the top now, we'll have 5 plus, we can combine our 10i and our 3i to get us a 13i plus 6 times negative 1. And on the bottom, similar thing is going to happen. We're going to have our 1. We can combine these two and they actually cancel out. So we have nothing left. And we'll have minus 4 times negative 1. So if we take it one step further, we have 5 times this is going to end up being negative 6. So we'll have 5 minus 6 over, oh, we don't want to forget our plus 13i on there. I'm just switching the order of things. And on the bottom, we're going to have 1 plus 4. So the final answer for this should end up to be negative 1 plus 13i over 5. We can't simplify that anymore because we have an I on the top, we have some addition, so that should be our final answer. So the final example here is actually a little easier than the last one because we don't have a binomial on the bottom, we just have that monomial there. So we want to go ahead and multiply through by whatever the radical is. In this case, our radical is actually just going to be the I. So we're going to do this twice because it only takes a second. The first time we're going to multiply through by just an I on the top and on the bottom. So on the top, we're going to be left with 3i minus 2i squared. On the bottom, we're going to be left with 2i squared. As we already know, the I squareds are going to turn into negative 1s. So this will give us 3i minus 2 times negative 1 over 2 times negative 1. Or a final answer of, I'm going to switch this out in front because it's the real part of the answer, a positive 2 plus 3i over a negative 2. Okay, and that will be our final answer. All we did was multiply through by an I so that it got out of the bottom. Now, if you didn't notice that you could just multiply through by I and you had 3 minus 2i over 2i and you multiplied through by that whole 2i, that's okay. It's just going to make it a little tougher at the end. On the top, if you distribute this through, you'll have 6i minus 4i squared over, on the bottom now, you're going to have 4i squared. Same thing happens with those I squareds, they turn into negative 1s. So you're going to have a 6i minus 4 times negative 1 over 4 times negative 1. And right away you should be able to see that the 6, the 4, and the 4 are all divisible by 2. So you end up with, if I pull that out in front, 4 plus 6i over 4i, over negative 4. And then you can simplify that down to 2 plus 3i over negative 2, which gives you the same answer we did before. You just had one extra step where you had to simplify. If you have any questions, make sure you make note of them so you can ask them in class and I can answer them. Have a wonderful night.